everybody, in this video we're going to be talking about ordering fractions, or in other words, how to tell whether they're greater than or less than each other. So if you have two fractions that have the same denominators, then you can just look at the numerators and determine which one of the numerators is greater than the other. So if A is less than B, then that means A over C is less than B over C. And if you have different denominators, you can cross multiply the numerator and denominator of the fraction and determine the order of the greater than or less than sign based on that cross multiplication. And when you're teaching this to students, you're not necessarily going to teach them these formal definitions. Instead, you'll teach them 4 different methods that they can use to compare fractions. So the first method is for fractions that have the same denominator. So for example, if we had 2/3 and 1/3, and we wanted to compare these two fractions, if you have common denominators, then you basically just look at the numerators and say, well, which one's bigger? So in this case, the 2 is bigger than 1, and so that would be the bigger fraction. And you can show this to students either with a region model where you have a whole circle that's split up into 3 pieces and 2 of them are shaded. And then you have a whole circle that's split up into 3 pieces and 1 of them is shaded. And when you show them with the region model, it's pretty clear and it's obvious why 2/3 is greater than 1/3, because the size of the pieces is the same, because the denominators are the same, and the number of pieces in the blue fraction is bigger than the number of pieces in the green fraction. And you can also show this on a number line. So if I take the distance between 0 and 1 and split it up into 3 pieces, and the first fraction, 2/3, is going to be 1/2 of those pieces. So this is the fraction 2/3. And then the fraction 1/3 is 1/3, or 1 piece along. That's also easy to see why 2/3 is greater than 1/3, because it's farther up the number line. Another strategy you can use is the idea of common numerators. So if you have two fractions that have the same numerator, then you can look at the denominators to determine which fraction is bigger. So the first fraction, we have 3/5, which means that our whole circle is split up into 5 pieces and we have 3 of them. And our second one is 3/7, which means that our whole circle is split up into 7 pieces and we have 3 of them. So on this one, you'll show the students and you'll say, okay, well, in both cases, I have 3 pieces, but my 5ths are bigger than my 7ths, because if you split a circle into 5 pieces, those pieces are going to be bigger than if you split the circle up into 7 pieces. So 3/5 is greater than 3/7. And this is one where I would definitely recommend drawing a visual model of this for students, because a common misconception that students will often have is they'll say, oh, well, 7 is bigger than 5, so 3/7 is bigger than 3/5. But when you draw them a picture of it, it makes more sense of, oh no, actually, if you split a circle into more pieces, then those pieces are actually going to be smaller, because you're dividing the whole circle into smaller pieces. And again, you can show this on a number line, or if you wanted to, you could also show it with fraction strips, because fraction strips are very similar to the number line model. So if I wanted to do that, I would basically take the distance from 0 to 1 and split it up into 5 equal pieces. And 3/5 is going to be right here. So that's the number 3/5. And then if I wanted to model the fraction 3/7, I would take the distance from 0 to 1 and split it up into 7 pieces. And 3/7 would be about right here. And again, you can see that the 3/7 is smaller than the 3/5, because when you split the distance from 0 to 1 up into 7 pieces, your pieces are smaller. So those last 2 examples are really helpful when you have either the same number as the denominator or the same number as the numerator. But sometimes you'll have fractions where the numerators don't match and neither do the denominators. And in that case, you can use a strategy called benchmark fractions. So the idea of a benchmark fraction is you compare your fractions to a really simple fraction that's easy to work with. So for example, if we had 3/7 and 2/3, a helpful benchmark fraction might be the fraction 1/2. Because if you think about the fraction 1/2, well, 3/7 is smaller than that, because if you have 7 pieces and you split those 7 pieces in half, 3 pieces is going to be less than half of that. And then if I take 2/3 and I compare that to a half, well, 2/3 is bigger than 1/2, which means that 2/3 is going to be greater than 3/7, because if 2/3 is bigger than a half and 3/7 is smaller than a half, then 2/3 has to be greater than 3/7. And you could also show this on a number line, because if you look at the benchmark fraction 1/2, well, 2/3 is going to be above 1/2, so somewhere up here, and 3/7 is going to be below 1/2, somewhere down here. And so that also shows that 3/7 is less than 2/3. And then the last strategy that you can use is to find common denominators. So in this one, they don't have the same denominator, they don't have the same numerator, and if you try to compare them to a benchmark fraction like 1/2, well, they're both less than 1/2. And from this picture, you can kind of see that the 2/5 is bigger, but if students are drawing these pictures on their own, they're not going to be able to tell whether or not 2/5 is greater than 1/3, because the 1/2 mark is greater than both of the fractions. And so in cases like this, you'll want to have the students learn how to find common denominators so that then you can use the common denominator trick to compare the fractions. So to find the common denominator, you look at the two denominators that you already have, and you're going to find the least common multiple of those two denominators. So I could do this with the set intersection model, and I could say, okay, well, the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, etc. And the multiples of 5 are 5, 10, 15, 20, 25, etc. And when I look at these two sets to find out what multiples they have in common, the least common multiple is the number 15. And so that means that I'm going to convert each of these fractions into a fraction that has a denominator of 15. So I'd say, okay, well, 1/3 equals how many 15ths? Well, I can multiply 3 times 5, which basically means I'm going to split each of these pieces up into 5 equal-sized pieces. Sorry, my drawing doesn't necessarily make them look equal, but it's fine. So if I split each of those thirds up into fifths, that gives me a total of 15 pieces in my entire circle. And the one piece that used to be shaded is now 5 little pieces. So 1/3 equals 5/15. Then I can do the same thing for this purple fraction, and I can say, okay, well, if I want to have 2/5 equal some number of 15ths, well, I can do 5 times 3, which means that I'm going to split each of these fifths up into thirds. So it looks like this. And when I do that, the 2 pieces that were shaded before are now 6 little pieces. And so 2/5 equals 6/15. And you can see when you look at these two circles that the size of the pieces are now the same, because both circles are split up into 15 of these little pieces. And so now I just look at it and I say, okay, well, if I have 5/15 and 6/15, well, obviously 6/15 is the greater fraction. And so that means that 2/5 is greater than 1/3. So this method is definitely the hardest method. So it's helpful to teach your students the previous 3 methods if it applies. So if the fractions have common denominators, you can use that trick. If they have common numerators, you can use that trick. And if you use a benchmark fraction and one of them's greater than a half and one of them's less than a half, then you can use that trick. But if none of those methods work, then you can find common denominators to compare the fractions. So why don't you go ahead and practice this? So order these fractions using whatever method you would like. Pause the video, complete that, and then restart it to see how I would solve it. Okay, so on this problem, if I were solving it, I think I would probably use the benchmark fraction approach because the fractions do not all have the same numerator, nor do they all have the same denominator. But if you compare these fractions to the benchmark fractions of 1/2, or we have some improper fractions as well, so we might use whole numbers as our benchmark fractions, that should give us enough information to be able to order them. So I'm going to kind of show this on a number line, but you could also show this with shapes if you wanted to. So here's the marks 0, 1, 2, 3, 4, etc. So if I think about the fraction 3/4, I know that 3/4 is bigger than 1/2, and so 3/4 is going to be about right here because it's kind of in between 1/2 and 1. Then the fraction 1/5 is less than 1/2, and that's going to be about right here. And then 7/3 is greater than the number 1, and it's also greater than the number 2. So 7/3 is going to be about right here. And 9/2 is greater than 1, greater than 2, greater than 3, and greater than 4, because the number 4 is 8/2, and 9/2 is greater than that. So 9/2 is actually going to be even further up on my number line, and it's going to be about right here. And so by using these benchmark fractions of my whole numbers as well as my half marks, this shows me that the smallest number is 1/5, the next smallest number is 3/4, then 7/3, and then 9/2. And that's how I would order those fractions. So let's do one more example. Take a look at these 4 fractions, and using whatever method you would like, put them in order from least to greatest. So pause this video and do that really quick, and then restart it to see how I would solve it. All right, so on this one, I'm not going to use common denominators or common numerators because none of my numerators or denominators match each other. So I'll think about it and say, okay, could I use a benchmark fraction? Well, I know that 2/5 is less than 1/2, and 9/20 is also less than 1/2, and 3/8 is less than 1/2, and then 1/2 is equal to 1/2. So by using the benchmark method, I know that 1/2 is my largest number, but I don't really know where the other ones fall in regards to each other because all of them are less than 1/2. And so what I might do in this case is find a common denominator between all of them. So to find the common denominator, I'm going to list out the multiples of all 4 of these denominators. So I'd say, okay, well, the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, etc. The multiples of 20 are 20, 40, 60, 80, 100, etc. The multiples of 8 are 8, 16, 24, 32, 40, 48, etc. And the multiples of 2 are basically all the even numbers, 2, 4, 6, 8, 10, 12, 14, 16, etc. like that. So when I'm looking for common multiples, I might say, okay, well, 5 and 20 both have a 20 in common, but 8 does not. So 20 isn't a common multiple of all of them. The next multiple it looks like that we have in common is the number 40, and that is a multiple of 5, 20, and it is also a multiple of 8. And my list of the multiples of 2 doesn't go up to 40, but if I did extend it that far, 40 is an even number, so it's also a multiple of 2. And so that means I'm going to find common denominators where the denominator of my new fractions will be 40. So I'm going to say, okay, well, if I have 2/5 and I want to make that into a common denominator of 40, well, I know that 5 times 8 equals 40, and 2 times 8 equals 16. So the fraction 2/5 is equal to 16 over 40. Then I can say, okay, well, if I have 9 over 20, that's going to equal how many 40ths? Well, 20 times 2 equals 40. 9 times 2 equals 18. And so 9/20 equals 18/40. Then I can do the same thing for 3/8, and I can say 3/8 equals how many 40ths? And I know that 8 times 5 equals 40, and 3 times 5 equals 15. So 3/8 would equal 15/40. And then 1/2, if I do that one, 1/2 equals how many 40ths? If I do 2 times 20, that equals 40. 1 times 20 equals 20. And so 1/2 equals 20/40ths. And then when I look at these fractions with common denominators, I can say, okay, well, it looks like they're all split up into 40ths now. And the smallest amount of pieces that I have is the 15/40ths, which is 3/8. So 3/8 is my smallest fraction. Then 2/5 is going to be my next one because 16 is the next smallest number. Then 18 is the next smallest number, so 9/20 will come next. And then 1/2 will be our largest number. And that's consistent with what we got with our benchmark fractions because all of the other 3 fractions were less than 1/2, and 1/2 is equal to 1/2. And so this would be the correct ordering for these 4 fractions. So if you have any questions, let me know, and I hope you have a great day.